Okay, so draw a diagram for sampling distribution. Let's draw a normal distribution. Remember that this normal distribution is made up of x bars. So the random variable is x bars. We already know this. And the mean of this mean distribution is mu x bar. And the mu x bar is equal to the mean of the original data. So this mean is 85. The standard error of this data is equal to the standard deviation of the original data divided by square root of sample size. Sample size is 64. So square root of sample size, I'm just going to write sample size here. Okay, so when I substitute the standard deviation, I'll have 8 divided by square root of 64. Square root of 64 is 8 also. Therefore, mu x bar is equal to 1. Mu x bar is equal to 1. So mu x bar is 1. The mean of the mean distribution is 85. So that is as an easy question. Okay, let's go to number 26. Question number 26. Suppose a simple random sample of size n equal to 15 is obtained from a population with mean of mu x by 64. Mu x by 64. So mu x bar is 64, and the standard deviation of the original data is 19. So for this number 26, I am going to clear all the things written above. Okay, so, and actually I can use my whiteboard. So now I'm going to use my whiteboard. So all the things given to me is that the mean of the data, the sample size of the data is n equal to 15. The mean of the data number 64, 26 is 64, and the standard deviation is 19. So the mean of the original data is 64, and the standard deviation of the original data is 19. Okay, and that's what we are given. Okay, that's what we are given. So the question is, what must be true regarding the distribution of the population in order to use the normal model to compute the probabilities regarding the sample mean? Assuming the normal model can be used, describe the sampling distribution. So describe the sampling distribution. For me to describe the sampling distribution, all I need to do is find the mu x bar. The mu x bar is equal to the mean of the original data. The standard error is equal to the standard deviation of the original data divided by square root of sample size. Okay. And the data must be normally distributed. It is from a simple random sample. So I have described it for A. B. So let's go to question B. So assuming the normal model can be used, determine the probability of x bar, the random variable x bar is 67.2. So I'm going to draw a normal curve. So draw a normal curve. the mean of this data mu x bar is 64. They want me to establish the area under the sampling distribution from x bar less than 67.2. So that point must be at the right-hand side of the mean, 67.2 percentile. So they want me to find the area to the left of 67.2. I already know that the negative infinity will be 1 e to the power 99. All right, so I am going to write the argument that I will give my calculator. So I'll tell my calculator that I'm looking for the area to the left of 62.7. All these are raw data, but you already know that my calculator can calculate area under standard normal curve. My calculator can calculate area under standard normal curve. So mu, normal CDF. So I'm going to write the argument normal CDF starting from the lower bound, which is negative infinity 1 e to the power 99, and to the upper bound, which is 67.2, 67.2. The mean of the central limit theorem is 64, and the standard deviation of the central limit theorem, which is standard error, is 19 over square root of 15. 19 over square root of 15. Okay. Now I get my calculator and put all this in and find the area inside the normal curve. Because that area is area to the left, it's also called percentile. Area to the left in a normal curve is called percentile. So I'm going to fit that into my calculator. So I'm going to turn normal CDF on in my calculator, second distribution, normal CDF. The lower bound is negative infinity. It's already here. I don't have to put it in again. Even though that this data is not standardized, I can still use it. My calculator is intelligent. It knows how to calculate area under the normal curve, even without standardizing it. So upper bound is 67.2. The mean of this data, the raw data, is 64. The mean of the sampling distribution is 64. And the standard error is 19 over square root of 15. 19 divided by square root of 15. Square root of 15. And I'm going to put 15 here. When I close parentheses and I hit enter, my answer is 0.74, approximately 743 to 3 decimal places. So the area to the left is 0.743. So that is 74.3%. And this can also be called percentile. So it is 0.743 percentile. So the area to the left of 67.2 of that data is 64.3 or 0.743. So we have answered this question. The question in, let's look at that question again. So that question says, B, since the sample size is large enough the population, okay, that's B, A. Assuming the normal model can be used, determine. So I just found the area to the left of 67.2. So the next question is C. Assuming the normal model can be used, determine area to the right. So I'm going to do area to the right. So this is another question, area to the right of 66.4. So let's find area to the right of 66.4. So I am going to, everything is going to be the same except area to the right of 66.4. So I'm going to draw a normal curve and show the area from 66.4. So note that we are looking for area to the right. Find the probability. I hope you know that this is probability. Find the probability that the random variable is greater than or equal to, so you're looking for area to the right this time. So area to the right is not percentile. This is not percentile. So the first thing to do is to draw a normal curve and show 66.4. 66.4 is greater than the mean. The mean is right here, and the mean is 64. So 66.4. Here, approximately area to the right. That's area to the right. Okay, and so area to the right is from 66.4 to positive infinity. So let me write the argument I would use, tell my calculator. That argument is normal cumulative density function. The lower bound is 66.4. The upper bound is 1e to power 99. The mean is 64. The standard error is 19 over square root of 15. 19 divided by square root of 15. Okay, so now that I have written the argument, I will put in my calculator. I will pull my calculator up and find area to the right. So let's find area to the right of 64.4, 66.4. So I'm going to clear and go back to second distribution, number 2. Okay, so the lower bound is 66.4. The upper bound is positive infinity, 1 e to power 99. E is above common, don't forget. 1 e to power 99. The mean of the standard of the sampling distribution is 64, and the standard error is 19 divided by square root of 15. So now I'm going to calculate, and I'm calculating area to the right. I'm calculating area to the right of 64.5. All right, so now I'll hit enter, and my calculator is asking me, is that the argument you want? Yes, that is the argument that I want. Therefore, area to the right is 31.23. Area to the right is 31.23%. So 31.23%. I can write it in decimal. This area to the right. So the area to the right of 66.4 is 31.23. Okay, I hope this is clear. So this is still about sampling distribution, but we're doing a review today since our test is on Friday. So if you do have any question, let me know. So we have solved many problems on Central Limit Theorem or sampling distribution, or you can call it sampling distribution also. Okay. So the next one now is we have already answered question number 26. So we have reviewed sampling distribution.